All right, Chapter 5, Section 1. We're going to use a word right here that you've probably seen before, and it's called a bisector. I think we've talked about that, haven't we?
Yeah, we have.
Okay, I think we've talked about bisecting segments, right?
Really?
So watch, if I had a line segment right here, and this is one end, and this is another end, we'll call it A, B. And if I said something about bisecting it, what am I doing? I'm putting a point here where it does what? It splits it. Now, yeah, into two equal parts. Very good. So you do remember that, don't you? Okay, now, yeah, technically you're right. You are splitting it in half. But what I really want you to understand is you're splitting it into two equal parts. Excuse me. So if I put let's say that's the midpoint right there. We'll call that M. Watch. This segment is equal to this segment. Guess what I just did to that segment? I bisected the segment. Okay? So you can have a bisector. You can have a point that bisects a segment. You could have a line that bisects a segment. You see that? It goes through the midpoint, so that line bisects segment AB. You with me on that? You could have a line segment. You could have a ray. You could have all kinds of stuff that bisects a line segment. But we're not talking about line segments today. We've already discussed that in the past. I just want to refer that word to you again so you remember what that word is. What we're going to do now is we're going to take an angle, and we're going to talk about bisecting an angle. Well, actually, that's a little bit later. That's a little bit later. Let's just do this. Sorry, getting ahead of myself here. Getting all excited about the angle bisector. Let's go back to that, that line segment. All right, so let's say we had this line segment again. I'll just put it on here again, AB. So we've already talked about how to bisect it, but I want another word in there. Here's another word that we've talked about before. This is not a new word, but we're going to put the two together. Word perpendicular. What does it mean to be perpendicular? Two lines that form what? 90-degree angle, or a right angle, okay? So two lines that form a right angle. Now if I put these two words together, watch this, the magic of my little program here. Okay? If I put those together, I get a what? A perpendicular bisector. So what I want to do, I've got a line segment right here. I want to construct, or I want to draw, a perpendicular bisector to line segment AB. Well, two things must be true. It must bisect this, so where must it hit?
In the middle?
Okay, at the, let's not say the middle, at the midpoint. At the midpoint, okay? So the midpoint looks about right there. Okay, we'll call that M for midpoint, okay? But that's not perpendicular, is it? We want a line or a line segment, okay, that goes through the midpoint, but is what to the line AB? Line segment A, perpendicular to it. Okay, so what I'm going to do, I'll just start it right here. Make sure I go through it. And then that right there, and let's just extend it down about like that. If that is a right angle, all right, if that's a right angle and it goes through the midpoint, watch, AM is equal to MB. Did you agree with that?
Yeah.
All right, so if that's the midpoint, AM and MB must be equal to each other. And if this line right here, we'll call it line L. Is that all right? So we'll call that line L. If line L goes through the midpoint and is what else? Perpendicular, then what do I call line L? Line L would be a what?
Perpendicular.
Perpendicular bisector. Everybody understand that? That's pretty simple, isn't it? Okay, so that's a perpendicular bisector. This doesn't always have to be going straight across like this, looking, yeah. Let me see if I can do this. Watch. Okay, it's acting a little slow. Watch. What if I did this? Oops. Trying to get all fancy and I can't do it. Hold on. Let's try this one more time. No. Alright, let's get this stupid word out of the way. Then I can do it. Watch. There we go. And if I take this, it's still a perpendicular bisector, isn't it?
Yeah.
Alright, because this doesn't have, my whole point is this, it doesn't have to be going straight across horizontally and straight up and down vertically. They could be at angles, but as long as this hits this line right here, perpendicular, and at the midpoint, then it's a perpendicular bisector. All right, I think we've covered that well enough, don't you? Let's go through a theorem and talk about a theorem that uses this perpendicular bisector stuff. Let me draw it out. Okay, we're going to have another situation. I'm still going to, it'll look like I'm repeating myself, but we're going to talk about being a little bit different. Let's do another perpendicular bisector. All right, again, we'll just call it AB again, just for the fun of it. All right, and that looks about the midpoint right there. And I want to draw a perpendicular bisector again. So everything looks pretty much, oh, I missed it, didn't I? Everything pretty much looks the same. Let's slide that over so it hits at the midpoint. Okay. Everybody with me? Now, look at this point up here. We'll call this X. Look at this point right here. If this is a perpendicular bisector, we'll call it tell you what, let's not call it X, let's call it just CD. Is that alright? Be consistent with what the book does. If that's C and this point right here is D. Alright, I said it's a perpendicular bisector, so there we go. So that line right there is a perpendicular bisector. But just looking at this drawing, can I just look at that drawing right now and say it's a perpendicular bisector? No, I'd have to know a couple things. What would I have to know in order to say that's perpendicular bisector? AM and MB are equal to each other, and what else? You got to have the right angle in there. Okay, now, looking at this picture, can I say it's a perpendicular bisector? Yes. Yeah, I can. What's interesting is this. This is the theorem part of it. All right? So all we've done so far is just talked about the definition of perpendicular bisector. So what if I did this? Watch. If I took this point right here at C and I connected it to the end point of that segment, what do you think might possibly be true about from here? Yeah, it's a right triangle, but that's a little too obvious. What about if I went from C to A, what do you think might be true about C to B? Yeah, they are equal to each other. Look, I'm going to do like a little proof here. How do I know that those two red lines are equal to each other? Well, check it out. I've got a what? A side, an angle, and I got this third side right here, don't I? So what's true about this triangle and this triangle? They are, we don't say equal, we say they're what? They're congruent. Now listen to what I said. I said side, angle, side, right? So these two triangles are congruent. If they're congruent, if I took those two triangles apart and smashed them together, all the other parts would match up, right? So this and this would match up. So guess what must be true about AC and BC? They're going to equal each other. Exactly right. So here's what the theorem says. They call it the perpendicular bisector theorem. All right, that's the stretch, isn't it? All right, it's not very creative, but it makes sense. There's a perpendicular bisector. The theorem says this. I could take any point on the perpendicular bisector, and it's going to be equidistant, the same distance, from the endpoints of that segment. You hear what I just said? All right. I don't think you did. I got people looking all around. I don't have people paying attention to me. This is not a good fresh start. Remember we talked about having a fresh start at the beginning? Okay? That's not a good fresh start. A fresh start would be everybody taking notes and watching me and listening to me. Okay? But we're falling back into the same trap as what we did before. So let's pay attention. Let's wake up. Let's see what I'm saying. This point right here. I could take any point. It doesn't have to be exactly that point right there. I could take any point on this perpendicular bisector. I could take a point right here if I wanted to. And guess what? If I connected, let's do this in a different color. If I connected from here to A, and then what else? From that point to B, guess what's true about those two blue lines? They're going to equal each other. I could take any point on this perpendicular bisector, and if I connect it to the endpoints of that original line segment, you see that, A and B, then those two segments right there are going to be equal to each other. Does that make sense? Okay. I could go anywhere. I could even go, if I wanted to, let's change colors again. Let's go green. I could go, I could take a point even down below here if I wanted to. Watch. And I connected from this point to B, and then I connected from that same point to A. Guess what's true about those two? I know they might not look green to you, but they are green. These two ones down here, what must be true about them? They're going to equal each other. So any point on the perpendicular bisector is equidistant from the endpoints of that original line segment. Everybody see that? Okay, so that's pretty important, because what are they going to do? They're going to give you some lengths. They'll say this is, I don't know, 5, and they'll say, okay, this is a perpendicular bisector. What is BC? Just looking at it. If AC is 5, what's BC? 5. It's 5. All right, just looking at it. Why? Because the perpendicular bisector theorem that says any point on the perpendicular bisector is equidistant from the endpoints of that line segment. You got it? So if I told you this was 3, then what would, call that E, what would BE be equal to? That would be 3. Make sense? That's easy stuff, isn't it? Should just be able to look at it and tell. On the test, we had a problem that said, I'll just sketch this out real sloppy. Okay, watch. Forget which problem it was, but it was this, and that was 7. I can't believe that people actually missed that this side right here was what? Was 7. Was there any math involved? Did you have to set anything equal to anything? Did you have to do any algebra? No, you just saw that the 2 tick marks, if this is 7, that has to be 7 as well. And I still got people that missed that. Not a lot, but there were still people that missed that. All right? So don't let that happen on this chapter. If I told you that this was 5, then BC would be 5 as well. Everybody got it? Okay, not that hard. Let's switch things around a little bit. What if we said, I'll tell you what, let's redraw this again without all that mess. All right, here's our situation. This line, this up and down line right here, I didn't label or anything, but this up and down line right here, is that a perpendicular bisector? You don't know it is, do you? Now, it could be, and actually technically it is, because I did find the midpoint, and I did make sure that that was perpendicular. But by the information that you see right here, can you say that that's a perpendicular bisector? No, you can't. But watch what's going to happen here. I'm going to tell you this. So it's not given that you have a right angle. It's not given that that's a midpoint. But it is given, watch, that this, what do you think, is equal to that. All right? So we're given, I guess we should label these, shouldn't we? Let's call that AB, let's call that C, and let's call that D. All right? So we're given that AC equals BC. That's all we're told. All right? If AC and BC are equal to each other, what do you think you could say about this line right here? You could say it's not just a bisector, but a perpendicular bisector. Exactly right. So listen to what we've got. The first part said, if it's a perpendicular bisector, I'm just jotting this real quick here. If it's a perpendicular bisector, then we'll call it just the sides, okay? Then the sides are what? Equal, okay? What do you think this part right here says? If what? If the sides are equal, then it lies on a what? Perpendicular bisector. Do you see the difference? That's our theorem. This is called the converse of the theorem. If I change the if and then, and I switch places with them, right? I take the if part and I put it where the then was, and I put the then where the if was. Does that make sense? If I switch them around, that's called the converse of the statement. Both things are true. So if I'm given that it's a perpendicular bisector, I could tell you that AC and BC would be equal to each other. But what do they tell you this time? They just say that AC and BC are equal to each other. What does that tell you then? That tells you that it lies on the what? That this point lies on where? On the, come on, we said it like 10 times today, on the perpendicular bisector, okay? Which means, if that's all I was given right there, that's all I was given, what could you say about this angle right here? It's a right angle. What could you say about AD and BD? That they're equal to each other. Everybody see that? And the only thing I knew was that this side and this side were equal to each other. But if they're on a line right here and it connects this endpoint to this endpoint, it must be on the perpendicular bisector. Everybody got me on that? Okay. That's not so hard, is it? Okay. Let's see what else I want to say. I'm running out of time though, aren't I? That's not us. Let's do an example or two, and then we'll shut this down, okay?